So I'm going to skip some of the problems in the PowerPoint, but I want to solve this problem that might drive some of you guys crazy at the beginning, right? Because I mean, where do we start? Remember that the goal is to rewrite this or have it look like ax squared plus bx plus c equals 0. So we have to set this equal to 0. So the first thing that we have to do is get rid of those denominators, or, or get rid of the fractions, right? So a way to get rid of two fractions is to get the cross products. So when you have two fractions, the cross products are always equal to each other. So if you multiply this two numerator and denominators, that is going to be equal to the other cross product. So let's take advantage of that rule. So I'm going to multiply the first numerator times the second denominator, and that has to be equal to the second denominator times, the second numerator times the first denominator. So let's see what we can do here. The goal, remember that the goal is to set this equal to ax squared plus bx plus c equals 0, or make it look like that. So let's do some quick foiling in here. So you can do the little square if you want. For x minus 2, x plus 2, and we're going to start filling up the square. That's x squared, 2x, negative 2x, and negative 4. So if we combine the like terms in the middle, those are going to cancel out. So the result from this, or from foiling this situation, is going to be x squared minus 4 equals 5x. Now we're just one step from making this look like the quadratic equation. So we have to get rid of this 5x, or send it to the left side, so that we have everything on the same side equal to 0. So since that's a positive 5x, the way that I'm going to get rid of this is by subtracting 5x. And if I do that, I'm going to do that also to the left side of the equation. Now on this, at this point, I'm going to rewrite this in the correct order, the x squares first, and then the x's to the power of 1, and then the constant. So here's the same thing. Okay, these two cancel out, so it becomes a 0. So why am I writing it like this? Because we have to get the correct values for A, for B, and for C. Okay, so at this point, my value for A is the one that comes with the x, which is the number. Right, there's a 1 in there. So A is going to be 1. In this case, B is going to be the number in the middle, which is negative 5. Make sure that you include that negative sign also. And the value for C is going to be negative 4. Okay, the last value of the equation. So now that you have those values, it should be fairly simple to substitute in the quadratic formula. Negative b plus minus the square root of b squared minus 4ac divided by 2a. So that's the same as x equals negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So I'm going to plug in my values. The value for b, the first one that I'm going to plug in, that's negative 5. That's my value for b. The value for a, that's a 1. And the value for c, that's a negative 4. Okay, can you see why it is important to keep the parentheses so that we don't lose any signs in here? Okay, especially in the first operation that we're going to do, that's x equals. Can you see it is really simple to lose these negative signs over here? So you have to be careful. I have, the formula says negative b, and my b is negative 5. So I have two negatives placed in there. One comes from the formula, and one comes from the value. So can you see why this is going to become positive 5? And that makes a difference at the very end. So be careful with that, that negative sign in there. Make sure you don't lose it. Okay. Then plus minus the square root of, I'm going to start doing the operations inside the parentheses. The first number, the b squared, is always positive. Since you're taking a square, you always make the number positive. So that's going to be negative 5 times negative 5, that's 25. The next operation that you have to take care of is going to be this multiplication. And I have an even number of negatives, so that means that the result is going to be positive. And if I multiply the magnitudes, that's going to be positive 16. It's positive 16. 4 times 1 is 4, times 4 is 16. And all of that divided by 2 times 1 is just going to be 2. That's simple. And let me see if I can keep going. X equals 5 plus minus, I'm going to add those two numbers inside the root. Remember that you don't take those roots individually, even though it looks tempting. You have to add those into the same value first. So 31 divided by 2. Now at this point, we don't have the square root of 31. So we will have to inspect or take a look at this, see if we can simplify it, right? So 31, we will have to split this into two roots such that one of them one of those two factors is going to have a square root. One of them is the greatest perfect square. Okay, so the perfect squares again are 1, 4, 9, 16, 25, and then it keeps going. And at this point, can you see that none of these numbers is a factor of 31? So in this case, what it means is that this square root of 31, it is the simplified form. You cannot simplify it any further. So this should be my result, the result that we are looking for. Since we couldn't find anything in here to multiply into 31 and one having a square root. And so this is a third situation, a different situation that we might encounter when we cannot simplify this root. It is in the simplest form. Okay, so this is the result that you're looking for. Of course, it has a plus and it has a minus, right? But we're not simplifying further since we don't want to lose accuracy on the result. Square root of 31, if you do it in the calculator, it's going to give you an irrational number, a number that never terminates or repeats. So at some point we will have to round, and we don't really want to round because we lose accuracy. So this is how we report the result. This is what we're looking for in the result.